All right, let's do this. We're going to make a video here for solving equations using logs. There's going to be different styles of questions. So one of the things you're going to have to be able to do is think on your feet when each different kind of question comes at you. However, the same rules are going to apply for most of these. So for this first example, basically what we have is we have the number 4 raised to an exponent is equal to the number 4 raised to a different exponent. So the only way 4 raised to a certain power can be the same is if they have the exact same exponents. So when we have the bases that are the exact same, we can just get rid of them and set their exponents equal to each other. And then we're just going to say that 7 is equal to x, and we're done. That's it. Game over. You are finished with that example. However, in the next example, you can't just do that because 36 raised to a certain power is going to be different than 6 raised to a certain power. So those exponents are going to be different. So what you want to do is you want to write this where the bases are the exact same. So there's not much you can do with the 6, but we do know that 36 is actually 6 squared, which is raised to an x minus 9. So now you can see that we have the exact same exponent again, or base. So now what we're going to do is we're just going to set 2x minus 18 equal to 2x, and that's going to give us, well, a false statement, because once you subtract your 2x, negative 18 is equal to 0. That is false, so we have no solution. So basically, 6 to the 2x power is never going to have the same value as 36 raised to the x minus 9 value. So nothing you can do here, so it's no solution. Next example, we're raising 25 to a power and 125 to a power. What does that power need to be for them to be the exact same? Well, we need the same base, so we know that 5 squared is 25. And of course, we're multiplying that to the x minus 1, because when you raise an exponent to another exponent, you multiply. And 5 cubed is the same as 125, so we can rewrite 125 as 5 cubed. And of course, we have our 4x. So now we have 5 to the 2x minus 2 is equal to 5 to the 12x. Now the bases are the same. You can just cancel out those 5's. We have 2x minus 2 is equal to 12x, which means after you subtract 2x from both sides, you're going to get x is equal to a negative 1/5. All right, so that's how you solve those styles of questions. If you have two sides where you have a number raised to a certain power, you want to get the base to be the exact same. Then the bases go away and you just set the exponents equal to each other and you're done. Now, to get a 2 as a base to go away, so we can get this x to drop down, you need to use something that we talked about in an earlier video, and that's called inverses with powers and logs. So in order to get this 2 to go away, you need to take log base 2 of it. So log base 2 of 2, bang, bang, goes away, and you're left with x. However, just like when you're solving an equation where you have to subtract 2 from both sides or divide 2 from both sides, you need to take the log base 2 of both sides. So this is where the change of base formula happens, where you need to say that this is a log of 31 divided by the log of the base 2. Type it in your calculator and you're going to get 4.954. Again, as we said earlier, round to 3 decimal places unless you hear me say otherwise. Okay, so also with inverses, e is a log base e, so which is known as the natural log. So in order to get rid of an e to get the exponent to become what you're using to solve, you need to take the natural log of both sides. So you take ln of both sides, and that's going to cancel out the e. So you have 2x is equal to whatever the ln or natural log of 6 is, which is approximately 1.792. Now you just need to divide that by both sides, and you're going to get x is equal to approximately 0.896. Okay, that's it. So a lot of these you're going to need your calculator for. Going back to the next question, this is some old school solving. In order to work with this, you need to get it by itself first. So your first step is to just subtract 5 from both sides. So that's going to give you 3 to the 2x is equal to 7. just like the problem right above it. To get the 2x by itself, you need to get this to go away, so you need to log base 3 both sides. So that's going to give you, cancel, cancel, 2x is equal to log base 3 of 7 in the calculator using the change of base formula is approximately 1.771. Divide both sides by 2 to get x by itself, and you're going to get 0.886. All right? So that's another one of those style of questions. Let's amp it up just a little bit here. Now we're going to have multiple steps to do in these questions. So the first one that you see here, first thing you have to do is add 6 to both sides. So you're going to have a negative 3e to the 3x is equal to a negative 2. Now you're going to divide both sides by the negative 3 to get e by itself. So we have e to the 3x is equal to 2/3. To get rid of e, you need to ln both sides. So you're going to be left with 3x is equal to the natural log of 2/3. So type that in the calculator, and you're going to get 3x is equal to approximately negative 0.405, which means after you divide by 3, x is going to be approximately negative 0.135. All right, so some of these are going to have more steps involved. Like in this next one, you think you might want to distribute that 2, and I'll tell you right now that's a bad idea. Why distribute the 2 to then have to later divide it out anyway? So just divide both sides by 2 now, and that'll give you your 3 to the x plus 7 minus 5 is equal to 4. Add the 5 to both sides, and you get 3 to the x plus 7 is equal to 9. And then you're thinking, all right, I just need to take log base 3 of both sides, and I'm going to ask you, why do you need to do that? You don't, because you should know that 9 is 3 squared. So 3 to the x plus 7 is equal to 3 squared. So now you have the same base. All you have to do is x plus 7 is equal to 2, so x is equal to a negative 5. Now, could you have done log base 3 of both sides with the calculator? Of course you can. If you type log base 3 of 9 in the calculator, or log of 9 divided by log of 3, it's just going to tell you the answer is 2 anyway. So you're still going to get x plus 7 equals 2. You just would not need to use your calculator for that specific problem. Okay? 2 more to go. Now, this one you treat similar to the very first couple of problems, where now you have log base 2 of both sides. So this is basically saying you're taking log base 2 of the same number if they're going to be equal to each other. So all you have to do is cancel out your log base 2's, and that's just going to give you x plus 5 is equal to a 3x minus 1. And then, of course, you're going to solve, and you're going to get your 2x is equal to 6, so x equals 3. Last example. This one's a little bit tricky. The reason why this one's a little bit tricky is because you need to get rid of this log base 3, and this side doesn't have a log base 3 like the previous example where they had log base 2's on both sides. So how do you get rid of this? And again, that takes you back to the inverse section that we had in one of the prior videos, where if this was a base of 3 raised to the log base 3 of x plus 5, we know that goes away. So that's exactly what we're going to do here, is we're going to turn the left and the right side into the exponent of a base of 3. So once you do that, you're going to be able to get rid of that log base 3, and you're just going to be left with an x plus 5. And now this is equal to 3 squared, which is 9. And then from there, all you have to do is subtract 5 from both sides, and you're going to be left with x equals 4. All right, that's it. That's your first of 2 videos on solving using logs and powers, natural logs and e's, and all sorts of fun stuff like that. Anyway, this is Longo, and I'm out. See you, bye.